Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi, everyone. Welcome to HPC News Bytes. I'm Doug Black of Inside HPC, and with me is Shaheen Khan of OrionX.net. In what EE Times calls a world first, a British tech startup named Ver said they've demonstrated what they call an Adiabatic Reversible Computing system with net energy recovery, unquote. Ver hopes to commercialize chips that can compute with virtually no energy being used. Shaheen, this is new to me, but according to EE Times, reversible computing dates back to 1961. It has to do with undoing computations to gain back energy to prevent energy being lost as heat. Ver's CEO, Rodolfo Rossini, came across reversible computing in 2018 while looking at what are called orphan technologies, which were ideas abandoned in the 1980s and 90s because Moore's law meant they weren't needed.
Well, when Moore's law was cranking out new chips, you could just wait a few months and a faster chip would show up. So yes, this is partly because of Moore's law. But this is interesting really because of AI. AI chips are running hotter and hotter, you need more and more of them, and there's no end in sight. So everyone is looking for ways to gain energy efficiency via new architectures like neuromorphic computing, new technologies like optics, new, more holistic energy management across the full data center, and now driving that concept all the way down to the transistor. For reversible computing, picture this. Energy flows in from a power supply to transistors to do the computation. When it's done, the result is held, and then the flow of energy is reversed back to the power supply to be used again. It's like pumping it back and forth instead of in one direction. And it can all be under the hood. One analogy I have seen is regenerative brakes in hybrid cars, but this goes further. Ver has built the actual logic gates and made it work with standard CMOS technology, which is not the ideal foundation. So they've solved a harder problem than required. But other big steps remain as they work to show that reversible computing can be commercially viable. Now, this can sound like a perpetual motion machine, and we know that is not possible, thanks to the first and second laws of thermodynamics. Energy is conserved and cannot be created, and energy transformation increases disorder and loses efficiency. As you mentioned, they call it, quote, adiabatic reversible, which means a system that is thermodynamically at maximum efficiency, but short of perpetual motion. It is not an attainable objective anyway, but getting even a little closer can be a big deal. So you want to avoid dissipating heat, and that leads to reversible, which keeps the system at equilibrium at all times, which allows you to take energy back and forth, but it also means it be slow. And you want to recycle energy, and that leads to adiabatic, which means a fully sealed system where zero heat goes in or out. Side note here, quantum computing fundamentally relies on reversible logic, and some of the logic gates in quantum computing, like the Toffoli transformation, are based on the same research by the same scientists in the 70s. Quantum logic operations, or quantum gates, must be reversible to preserve the delicate quantum states of superposition and entanglement, which all becomes irreversible the moment you measure the state.
There's other alternative chip news. The Financial Times reports that OpenAI is set to begin production of its own AI chips with Broadcom, which means OpenAI joins the list of companies trying to reduce their reliance on NVIDIA. Their order with Broadcom could total $10 billion, according to the FT, and the chips may ship as early as next year. OpenAI began its collaboration with Broadcom last year, and the chip will be for internal use as of now rather than availability to outside customers. OpenAI reportedly wants to double its aggregate compute capacity by the end of this year, so all of that will still be NVIDIA and AMD. But they've also increased their capacity by 15x since 2024, presumably had to delay the release of ChatGPT 4.5 because they didn't have enough capacity, said they will soon have more than 1 million GPUs, and also say they will have to figure out how to do 100 times that.
Yeah, we also have to remember their vision last year for a $7 trillion with a T global initiative to reshape the semiconductor industry. So it's not surprising that OpenAI would design its own chip, All big users have to evaluate that option, and we know Meta, Google, Microsoft, Amazon, Alibaba, and perhaps others are doing it, even as they stock up with merchant chips. Along these lines, last week we mentioned Google's latest TPU and liquid-cooled rack called Ironwood, expected to ship later this year. It's 9,000 TPUs with 1.77 petabytes of addressable memory and connected via an optical interconnect that uses AI to optimize speed. Well, it was reported last week that Google is interested in shipping these racks to GPU as a service, so-called Neoclouds. This is an excellent next step for Google to expand outside of its own walls.
Also last week, India announced a milestone with an indigenously designed and manufactured 32-bit processor called Vikram 32. It is designed by the Indian Space Research Organization, ISRO, and is a 32-bit follow-on to the 16-bit Vikram 1601. Both are manufactured by ISRO's Semiconductor Laboratories 180-nanometer fab, which was launched in 2016. It's another milestone in the country's push for semiconductor self-reliance, according to a story in Electronic Times. It's old manufacturing technology, but it seems to serve a very good series of use cases.
Very much. The processor is designed for space launch vehicles, so it is able to withstand a wide temperature range from minus 55 to plus 125 degrees Celsius, needs very little electricity, we're talking 1/2 of 1 watt, and uses a custom instruction set that is optimized for the Ada language, which carries on for many safety-critical systems and especially in the government market. The chip can be used in similar embedded environments in defense, aerospace, and automotive. It's an impressive little processor, and it's already been validated in space in one of their missions. India's technology prowess is not in doubt, so one should expect rapid progress. The country reportedly has more than 20 design startups receiving support from the Indian government.
Okay, I want to mention I was at last week's HPC User Forum held near Washington, D.C., and hosted by Hyperion Research. The conference drew more attendees than usual and had its usual high-quality roster of presenters discussing new developments in data center, in HPC AI, and quantum. Also notable were two major fundraising pieces of news in quantum computing. IQM, based in Finland, received $300 million, and Quantinuum, based in the UK and the US, doubled that with a $600 million capital raise. If you add a few others, quantum computing got over $1 billion just in September so far.
Not bad at all. And thanks to AI's eye-popping numbers, it doesn't even sound that big. I mean, OpenAI raised $40 billion in March, which brings its total to over $64 billion so far. We should also mention that Europe unveiled its first Exascale class supercomputer in 64-bit performance at the Jülich Supercomputing Center in Germany. This is the Jupiter system we've talked about in the past, built by Eviden and emerging as a showcase for a hybrid CPU, GPU, QPU complex. We'll see where it is in the top 10 of the next top 500 list in November. All right, that's it for this episode. Thank you all for being with us.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.